And good morning. We are picking up where we left off yesterday, searching for our white whale. So, what seems to be happening is that Salt 1 changes. You can see right now it's, what is this? 2,454,228,832. And it switches to 8,833 partway through the most current file. I presume because a wall log rolled. And then about 2,000 lines into the file, 2,500, it goes back to 8,832 right there. I'm not sure why that would be the case because the commit start continues to be the right values. So why would this go backwards in time? You can also see that the file that is being used during the write changes. So it's 8833, we have 54B0, and as soon as we go back to 8832, it becomes something else. So it's almost as though SQLite had opened two different files. Not sure why. I'm just toggling between the two at the moment. We're writing pages. One is about 4K off of the other. Music's perfect for this. Morning, Sam. How are you? Why would they do this? Let's search for this. Let's go back to first thing that it opened. Beginning of the file. Trying to open 54B0. Forgot which one was which. 54B0 is the new one. Wait, that's the old one. Look, this is 54B0, 5B80. 80 is the old one, B0 is the new one. Right. Where's my notes? Notes. Let's get a vertical split going. I don't remember how to split windows in NeoVim or how to resize them. Let's look that up real quick. Sorry, Helix. Split, move, split. Space mode. Huh. Do they not do that? Unanswered. Currently not possible as of that. Oh, okay. Yeah, I'm good. Good. Today's early day at work though, so still going to be a short stream, unfortunately. I really want to get this bug squashed. Okay. Just going to go with the Ghost TTY split. Just have Helix here. All right. Notifying change. I want this one and this one. Okay. Salt 2. Okay. Now the important bits are these lines here with salt 1 and salt 2, but also the line just before. So this one is for salt 2. Oh, wait, that's the same line. Come on, come on. Really? Oh, I know what I'm doing wrong. There. Okay. Now the previous one here, 33. Copy that into the system buffer. Okay, now we will go into the first buffer and see where these are actually opened and why. For instance, why was this file opened? So here we're opening this file. Hey Xenocron. It's been a minute. How are you? So we're probing for this information. You can see x-axis, and then we open. I presume this is the file associated with these lines. Work's been busy. You know what they say about idle hands, right? Wait, these are opened one after the other? Here and here? No. Why? Why? So we have these two things, two X opens happening, which means we open the file twice. And right now, we are associating state with this open. How's it going? Last time I checked, we didn't have a running project. We still got a couple months probably, right? I want to be able to build things on this by the end of the year. Now, our current status is that proxy, I'd say, is 80-90%. This side of the house is pretty good. Data plane, I think I just need to change the way that it writes to the database here. At the moment, it just updates the page immediately. So this little arrow here needs a little bit of a fixin'. At the moment, we're working on kind of this side of the house over here, chasing down a couple of bugs. We are currently able to notify data plane about a change, but it is not yet sending the mutations to data archive. We were in the middle of bench testing it and found an error, found something interesting that was happening. And it happens to be that it looks like we are opening the wall log twice, and I'm not sure why. The flags appear to be the same, but it seems as though we're opening the wall log twice. I want to dump a little bit more information here. Like, what is the name? Actually, the name is the same. No. Really? It's the same pointer. Bug chasing oh, I know. Well, aren't they all? Right? We're either bug making or bug chasing. And oh. But look, the pointer for the file name is the same, I think. No, it's different. It just happens to end in the same couple characters. The game is afoot. Let's add a little bit of logging so that we can see what's different here, and then we'll cause the error again, which is fairly easy to cause. You want that on a shirt. Programming is either bug chasing or bug making. Yep. And the better you are at programming, the more interesting the bugs are, because you've learned not to create the little bugs, the easy bugs anymore, which means you're only creating the hard bugs. It's off by one, behemoths. Here we go. X open. I want this name. Do I get the file name anywhere already? I'll just move that up. No. Da. Report user. Yes. Okay. Spam. Next. Spam. Next. There we go. Okay. So let's get this real quick. Let file name equals to, let's see. What did I call that? I thought I had a function that converted these. Oops, wrong button. It was here. Yeah, here it is. Oh, no. That one's a little different. But basically, we just need to do this. Let's just do that. Okay. There we go. We'll build and run it. Okay. Now, I'm going to pour some tea. So I've yet to do that today. Let's, let's crush it and crash it. So pour the tea. Okay, it crashed. Oh, I forgot to clear the log files. Let's make it easier on ourselves. Clear those. Yes, that one. Delete those. Thank you. Run it again. Good. Crush it again. Okay, it's good. Now let's come back over here. Close all of this out. Okay, we loaded 8 files. Right, now we can actually see the file names that are being opened, which is nice. All right, so here we open this. I'm going to copy this, set it aside. Okay. And DB3. Oh, I know I had opened twice. There's the wall. I know. I know why it opened twice. It's the exact same file. Oh, okay. Go back to the code. All right. So our little notes app just run here. Boom. Okay, it's running. Let's go look at it. What is WRK actually interacting with? It's this thing here, right? You can add a note. Boom. You can add another note, and it just shows you the last 5 notes. Super simple. Okay. So why in the world would we be opening the same database and the same wall files more than one time? Let me scroll to the hint here. All right, the hint's on page. That's right. It's because we have a database pool. So at some point, one of the connections in our threads decides it's going to rotate the wall log, but the other ones don't know about it. And then one of the other ones decides to write to it, but it's been rotated, and that blows up. I don't know if that's clear here, right? We have a SQLite database pool. We feed that into um, a router. We're using Axum, and so this is multi-threaded. So we're going to have more than one connection to the database. So if we go to current, where the crash happens, where is it? Do we not see it there? We don't see it there. Let's see it over here. Oh, let's crash it. Okay, so it crashed. Pipe error, right? I have it set up so that it's going to crash. So salt here, 5672. 5672. Data plan receives mutation. P672, source send error. This is still 5672. Ah, this is 5673. Okay. So in this case, this one rotated the wall log, this thread that's producing this message, and then the one that's producing the next message doesn't know about the rotation. 5672 says, this is great, I have new data. So for 5672, let's write at a certain place on disk, which isn't going to work because that place on disk is moved. Mm. So I'm surprised that this one didn't know that the wall log was rotated. I thought SQLite would handle that. So we have two different threads in app one writing to a file, and that file's been rotated. Okay. Hmm. So what are we doing? And why would SQLite not be aware of this? Because the second thread is trying to write at a certain place. Oh, but it is in sync. It is in. Okay, let me explain what I think's going on. Oh goodness. I'm just going to. Okay, so we have two threads, T1 and T2. Okay. T1 rotates wall log. I'm, oh, we're missing some steps here. T1 and T2 both open the same wall log, W1. T1 rotates wall log W1 and creates W2. T2 does not know about the rotation and later tries to write to the wall log. Now at this point, T1 writes much data to W2. T2 writes at the correct spot in W2, in W. Okay. T2 does not know about the rotation and later tries to make a write to the wall log. T2 writes at the correct spot that it still thinks is W1, but it should be W2. The only. But why is the salt wrong? Why is the salt wrong? SQLite two threads, basically two connections to the database. Shouldn't it know what the wall log is? Why would it not know about the salt changing? Because that's my doing. It's writing to the correct spot. It's writing to the correct position in the file. So it knows something. It just doesn't know that. So our code was never notified. Interesting. So how do we fix this? We need to share state between threads. Ooh, I smell an arc swap coming. Is it arc underscore swap? Here we go. As a container for an arc that can be changed atomically, semantically, it's similar to something like atomic arc blah or RW lock arc, but without the need for locking. Yay! It's optimized for read mostly scenarios, which is exactly what we have with consistent performance characteristics. I think we have to have some shared state. And this is going to be it. Because sqlite kept its pieces of data in sync, but our pieces of data became stale, as there's no way for our data to be synchronized between threads yet. Okay. All right. Let's close that. Let's go back to VFS file. So we have this here. So we have this wall state. Start, commit, end. Yeah, and even stuff like this could be missed, right? So the whole of the wall state needs to be shared amongst threads. Well, it shouldn't be an issue for mutating this data because SQLite prohibits multiple writes to the same file at the same time. So it's basically only one writer at a time, but we might have multiple threads. So they're handling the locking for that. So we could shove our wall state behind some lookup. How do I identify it? Because the pointers are all different. Only the file name itself is the same. We could create a quick hash on the file name. Well, Rust can do that. Does cster impl hash? Cster traits hash, yes. So we could do that. Ah, good morning. Raga. This here is called Tree Style Tab. It's a plugin. My buddy that actually used to work on the Firefox team itself, he was part of the GC team. Um, he put me onto this. It's really nice because to me it helps organize the data, and with screens being so wide, it just really works well for me. Let's see, was it this button here? Is it a plugin or an extension? Here we go. Manage, maybe? I'm looking for how to get a link for you. Details, permissions. Oh, here. Copy link. Let's take a look at that real quick. Tree style tab. Oh, why did it go away? Uh-oh. Okay. I don't know what version I have. Version 413. Okay. Oh, no, no. I don't mind. I don't mind. Okay. Actually, I'm really happy that I figured out what's going on. So, at this point, it's a little bit of a planning moment. Yeah, you're welcome. And it looks like really we just need to have the wall state consistent between writes. So, who holds the wall state? So, the wall state's on file. Um, what do we call it here? Reverb file holds the state. So this file state is an enum that has different kinds of state. But arguably this is not the right state. We need to have some lookup into some global location. Where would we do that? That would be in open? Where do we create file state and reverb file? That's in X open. So we get this here, this file, which ends up becoming a reverb file. Path is valid. It's null. Yeah, here we cast it. Okay. So we need some way of being able to get a shared state for a file. So we need like a hash map to a bunch of arc swaps. I wish I could use something faster than a hash map. Now let's just okay. No, we only need the hash map when we do an X open because we'll hash to the arc swap and then clone the arc swap and store the arc swap in the reverb file. Boom. Okay. So file state. This becomes. You know what? This will be like a arc swap, something like this. So it's not expensive. We already have it. Okay, lovely. Let's add arc swap to this project. Cargo. Do we have? Oh, we already have arc swap. Okay, let's add it to the VFS. All right. Close that. Close that. Arc swap. All right. Tuple variant defined here. Yes. All right. So yeah, there's a bit of some unwrapping going on, but I want to get the setup done. Where is X open? Come back here. And it's basically file name to something else. But we need some global state for that. I'm hesitant. Where do we want to add that? I want to start having our global state in a consistent location. So right now we have these here. We have another static of a mutex to a hash map. What would that look like? Static wall states. Let's say it's a once lock of a mutex to. It wouldn't be an option, would it? That would just be a hash map. Uh, C star. Do we want to clone that? I don't really want to clone that. I want something that basically represents a C star, right? Can we just get a hash and use that? Can we just have a U64? Hmm. There might be a situation where two things have the same hash. We have an arc to a C star. Collisions? No, I know, right? Hash map from that to a arc swap of wall state. Let's see how many closing. Is it that many? One, two, three, four? Yep, okay. Import. Oh, it's not. Oh, yes, because it's like a stir. You can't have to be a C string, the owned type. If there's one thing you learned at your last job, is to use UUID 4 to avoid collisions. They really believed it, though. What's the new hotness? UUID 7, V7? Because the beginning of it includes basically a timestamp. I might have that wrong. Is it V7? Okay. Can I find the C string? the trace send is not implemented for const pointer to IA. It's required for wall state. Okay. Required for hash brown. To implement arc swap, I need to implement send. Yeah, that again. I don't know if you remember. Right? Yeah. Basically, we need to assure that the things that it points to don't change during the lifetime of it. Yeah. What was it? UID v7? Why does it to sequential integers? Hello, UID7. Whoa, that's bright. Okay, dark mode. Thank you. Check out the box. Oh, and watch how the second set of characters update incrementally. So we generate a new one. Oh, do we? Yeah, it's going up the second set. Neat. It's time-based, much like UUID v1. However, it offers a precise timestamp, up to 50 nanosecond resolution. Oh, wouldn't that be crazy if computers were synced within 50 nanoseconds? The core feature is okay. Time sortable property, meaning that newer UUIDs generate will be greater in value than the old ones if the time sync was correct on the machines. They can be naturally sorted based on creation time. Okay. So as long as you don't care about just slight differences across the machines and just kind of shuffle them together, you're fine. Natural sorting, optimized indexing. Yeah, this is why it's gathered a bit of attention. So there you go. UUID 7. All right, so we might have to basically do the same thing for the other code, wall state. Does it promise sqlite 3 file name, static stir? No, some of this can't be in here. File name pointer can't be in here. This is specific to the thread. So we have shate, state, and shared wall state. I was about to say shared, and I butchered state. Yes, it's mostly a ULID. Um, I forget exactly, but it's supposed to be also easier on databases. The indexing mechanism in databases. I forget why though. Okay. So let's rename this to shared or just wall shared state. There we go. And then we will also have wall state, which might have, what would that look like? Create wall state. Let's say that it has shared, which is like swap of a wall shared state. something like that with a couple of extra little bits here. Some bits and bobs. Reverb. This doesn't need to be in here. What truly needs to be shared? The flags, assault, and these bits here. Reverb, that's global. The real power move is to store them as strings. Yes, yes, of course. Store the AUIDs as strings. Pyrocat, thank you for that follow. All right, we've got about half an hour to make this happen. All right, so we'll come back to this. Let's go to reverb file again. Reverb file. Now, the file state is not this. It's going to be wall state, going back to what we had before. But the wall state has the arc bits in it. Okay, let's make it debug. I need to get my macros or snippets set up. And we will have just the wall shared state outside. So going back to lib, the end here, wall shared state. Yes, that can't be shared or sent safely between threads because Rust cannot validate that this would not change. We happen to know that this will not change. Or do we? Do we do it? It will change. Is that an issue though? Because of the way that SQLite writes to a database, they do all the locking and then we change it. So we're essentially in a mutex while they're calling us. So we can change this while we're in a mutex. We should still be okay. I think we can impulse send for this just fine. Are you opening the same database file multiple times? Yes. And the reason for that is this here. Wait, where to go? So we're using Axum, right? Multi-threaded web framework, but we also have a SQLite pool. So yes, the same database is opened multiple times due to the SQLite pool. As you can read from a database many times at once, but you can only write to a single database at one time in one thread. And that's the big limitation of SQLite, is that you can't have concurrent writers to a file. However, if you shard your data correctly, you can write to multiple files at the same time. So let's say you're writing a giant forum, right? Don't put every thread in one gigantic database, or like split it up. It's a read-write log scenario, kind of. At this point, we happen to be in a mutex that is in SQLite, right? We're actually operating as a VFS, as a plugin into SQLite. And I'm just, dare I say, familiar with the docs and architecture of SQLite at this point, that I know that they will not call us from multiple threads at the same point while we are mutating this value. So, safety. SQLite will not allow for mutating the same wall log at the same time from threads. So we actually have to impulse send for this object because we can validate it. Rust doesn't have enough information. Yep, SQLite takes care of it. Okay, coming back here, the very end. Oh, what's the next error? SQLite 3 cannot be shared and sync. I think we're okay with this too. Can we impulse sync the same way? And we just tell it it's sync. I don't think that we can get into a situation where this is half mutated and it causes an issue, because that would have to do with reading while we are writing. Sorry, I'm just trying to validate this here. Trying to spend a minute thinking about it. Thinking like, oh, well, what if we update this little bit of data, but then this data is used or something? But no, these all happen during a mutation. Like the access for these, it's only mutation based. The read stuff we just let pass through. I think we're good there. Technically, I think we could get rid of arc swap at this point. Basically, what we're doing. Arc swap can be used instead. Fig. So we need to initialize this. Where does initialization happen? Where does this get initialized? There. Here, we're just going to stuff it with a mutex and a hash map. All right, it's initialized. And I think we should probably put that Oh, no, no, we are in init. This will only get called once. Okay. All right, so wall states, we have our global state that will be shared between threads. Now we have to use it. Where's X open? X open. There. So we have the file name. Now, here. At this point, we try to create wall shared state, right? A bunch of stuff is messed up here. We split that into two structures. So we will probably have to call wall state new and pass in any shared state. So the plan is check to see if shared state exists. Hmm. Will SQLite open two files to the same? Sorry, will SQLite open the same file from two threads at the same time? We have a mutex though, right? We have a mutex to a hash map, so that's okay. Yeah. SQLite handles it though. They have this block of shared memory for wall logs that they use for synchronizing between threads. It's pretty cool. Create or load shared state. All right, let's get the shared state. And what is this going to look like? Wall state new. Import. Because some of this does not belong. Ah, it's on wall shared state. The new is. Okay. Let's create a new for wall. So this no longer has these. Okay. Generate impl. I just want impl wall state. Oh, the function new. No. Fill that. We will be passed in the shared state. So we have an arc there. Reverb is also passed in. Wasn't sure if that was. I wanted to think through everything before getting too far. And oh yes, just the file name pointer because the file name is created after that. Okay. Now here, from UTF-8 pointer, drop that in there. We have our file name. Done. Okay. Get rid of those. And this, that. It's not there anymore. Technically, that's. Yeah. Okay, so while shared wall state no longer needs that. Okay. And I am so surprised more isn't broken here. There we go. So FIFO, some things are missing, which is fine. We might create little pass-throughs for these. We'll see. Okay. So coming back to lib. No, X open. Where's X open? It's in VFS. Okay. File name's gone. Oh, really? Why would I do that? I liked having that there. Oh, from pointer. What's it? Z name. There we go. I want to keep that. In this case, we want the underlying file and the flags. There were three. What's the third one? Oh, yes. Shared state itself. Ah, yes, the arc swap any bit. Okay. We use arc swap any. Arc. So we'll use an arc. There we go. So we have that. We can pass that through, but we're not sharing it yet. all states dot. What's the type on that? It's once lock. So we call get on it to a mutex. Oops. Get. And this returns an option to a T, but it's already initialized, and we know this. Lock dot unwrap dot. Here we go. Entry or a specific key. File name dot or insert with okay. Or we do an or insert with key. I don't know. Insert with. And in this case, we have to return the value that is being inserted, which would be that. But we need the file name. And this is only going to return a mutable reference to it, which means we need to clone that. What is this type? Ah, yes, we need an actual. Just going to be explicit there. Does that produce a C string? It does. Good. All right. And our state at this point is immutable reference to an arc swap any. Perfect. So in this case, we want to get a new arc swap any. We just call load on it. Now I want to see structs arc swapped any. Load returns a guard. I want a copy of this. I want to clone it. Arc swap from arc. I don't see it. Where did I use this elsewhere? Used an arc swap. Arc. Oh, that's this file. Really? I thought I used this with proxy main. I really thought I did. Proxy cargo arc swap. It's right there. Did I use something else from the crate? Arc swap. Structs. That's it. Arc swap. Huh. Fascinating. All right, I got 4 minutes. I might not make it in 4 minutes. Read, copy, update. Atomic storage for arc. And two inner load full map view. New. Fascinating. All right. So in this case, there is no sharing of it. You just go to the singleton. However, I don't want to do that because I don't want to do the hash map lookup for every IO operation. So I can't have this. I'll have to think about this. I really wanted to use that. However, I have to get going. So we're going to raid and run. Who shall we raid today? Let's see, anybody doing Rust? Oh, they changed the filters. Interesting. All right, we're going to raid Crystal. All right, y'all. Till next time. Bye bye.